Ooh, hello.
Ooh.
Hi, ladies and gents. This is Mrs. Bunt and Mrs. Burke, and we are going to review with you Chapter 3, 3.1, which the key concept is chemical reactions alter arrangements of atoms. This information has, this section has a lot
Hi, Peter.
Hi, Peter. Say hi, Peter.
I'm Miss Burke from this one.
Okay. No, you can't come on video.
What is it?
We're making a video.
Oh.
So now back to the
All
information.
right, now back to our show.
As we reviewed in class today, the textbook highlights 5 key vocab terms. However, there's about almost 20 concepts, 18 to 19, that we feel you really need to master.
A lot of information. So, without further ado, the first term that you learned in your reading was chemical reaction. And a chemical reaction produces a new substance by changing the way the atoms are arranged.
Okay. After a chemical reaction, the book talked about physical changes. Physical changes, there's chemical reactions.
Sorry.
That's okay. Physical changes. Physical changes are going to be able to not produce a new substance. Okay? So the substance itself is going to remain unchanged, but you are going to notice changes about it. It might just be a change of state, going from a solid to a liquid, or a liquid to a gas, or a liquid to, did I say solid? I did.
Mm-hmm.
Okay. It might be something simple where you're just changing the pressure of the item that it's under. But the atoms and the compounds that make it up will not change, and they will not be altered.
However, the next term that will be on page 71 in your book is chemical change. This time you have an original substance changing into a different substance, and it cannot be put back to the original substance. For example, water can go through a process called electrolysis. Once it has gone through this process, it cannot go back to being water, unlike a physical change where water can go from the liquid form to the solid form, ice, to the gas form.
And we're going to talk about that a little bit more in class with some worksheets to help you out master the chemical change and physical change concept. On page 71, the next thing that's talked about is going to be the first part that you're going to find in a chemical reaction, and that is called the reactant. The reactant. Okay? The reactants are the substances that are present or there at the beginning of a chemical reaction. Think of it as this is the stuff that you're going to start the reaction off with.
Then you have your product. Those are your substances that are formed by a chemical reaction, and that's what you're going to end up with. And if you look at a chemical reaction, there's going to be an arrow in between the reactants and the products.
Yes. Now, starting on page 72, the textbook talks about evidence of chemical reactions. Evidence is going to be just that, things that let you know a chemical reaction has occurred. And there's going to be 4 important ones that you must know from your reading. The first one is going to be on page 72, a color change. This is going to be when substances often change color during a chemical reaction. We had that happen when we were doing the conductivity lab. Do you remember some chemical changes that let you know, oh, there was a chemical reaction going on? Correct. It was when we had the color of blue, the table salt changed orange. So those are examples of color change.
Our next example is formation of a precipitate, and that's a solid product that is created during a reaction. And it forms when 2 liquids react. Your book talks about seashells on page 72, forming a precipitate. But we also had a precipitate when we did our lab.
Yes, we did.
Anybody remember? That's right. When we had little things floating around in our cup.
We had floaters?
Yes, we had floaters. When we swirled the cup, those were precipitates.
Good. Now, the next type of evidence of a chemical reaction is going to be a formation of a gas. Formation of a gas is an excellent one because when you add vinegar to baking soda and you place the container you place a balloon over a container, you can get the balloon to inflate. This is an example that a gas has been formed. If you take antacid pills like Rolaids or Tums, if you have a tummy ache or if you have heartburn, one of the things that you see people do is, and they're burping because that's creating a gas with the stomach acid.
The next piece of evidence that a chemical reaction has taken place is a temperature change. This is very easy to see, for example, when you use those hand warmers to keep your hands warm, or ice packs when you are injured. That breaking apart of that ice pack when you bang on it starts a chemical reaction that takes place that either leads to a decrease in temperature for the ice pack or an increase in temperature for the hand warmers.
Okay, so those are going to be the evidence of chemical changes. The next thing that you're going to have is going to be types of chemical reactions that are starting on page 73. And there's going to be 3 important ones that we're going to cover, and then we'll talk a little bit more about some others in class. The first one that we'll talk about is called a synthesis reaction. And what a synthesis reaction is to synthesize, to put together, or to make. So a synthesis reaction is when you are going to have 2 individual elements combine to make one compound. An example of a synthesis reaction might be hydrogen plus oxygen gives you 1 molecule of H2O or water. So that would be the making or the synthesis reaction.
The next type of reaction is decomposition, and that's when you start out with a compound in the reactant, and that compound breaks down into simpler parts. It's the reverse or the opposite of synthesis. So if I start with a water molecule, it will break down during the chemical reaction, during the decomposition reaction, into hydrogen and oxygen.
Okay. The last type of chemical reaction that's mentioned in your book is called a combustion reaction. Combustion reaction is a little detailed because the first thing in a combustion reaction is one of the reactants is always, without a doubt, always oxygen. Okay, and then the other reactants are often either carbon or hydrogen, and when they usually come together, there is going to be burning or an explosion. So this is a reaction where one reactant is always oxygen and another often will contain carbon and hydrogen, or it will be a molecule of carbon and hydrogen together, and the end result will be some type of burning or explosion.
Now that we've talked about types of chemical reactions, we are going to talk about ways to vary the rates of chemical reactions. And the first way that we can do that is concentration. And that has to do with the number of particles present in a certain volume.
Oh, it's not thinking really hard?
No.
It was concentrating.
No, and it's not that game you play when you flip 2 cards over and try to make a match.
Okay.
Concentration, for example, when we did the conductivity lab last week, concentration would be changing the amount of salt, table salt or Epsom salt, that we poured into the distilled water. Pouring more table salt in will increase the rate of the chemical reaction. Using less table salt will decrease the rate of the reaction. That is concentration.
The next thing that can affect the rate, how fast a chemical reaction occurs, is going to be the surface area. If you take the surface area and you have something very large, it's going to take longer for that chemical to react with it. But if you increase the surface area, it's going to happen faster. So one thing that you could do is you could break something up into smaller pieces. If I turned around and I took one whole piece of wood and I put it on the fire, it's going to take very long for that piece of wood to burn. But if I chopped it up into pieces of sawdust and then threw that on the fire, it's going to burn really fast, really bright, and really large. So by increasing the surface area, I've exposed more of the sides of that item to come in contact with the chemicals so that it's going to be able to react faster.
Another way to change the rate of a chemical reaction is by changing the temperature. Again, we did this last week when we did the conductivity lab, because if you will remember, we heated the table salt and the Epsom salt, and the reason why we heated it was because we wanted to speed up the reaction that was taking place. So again, speeding or increasing the temperature will speed up your reaction. Decreasing the temperature will slow down the reaction.
And the last thing on page 76 that's talked about that can affect the rate of a chemical reaction is going to be a catalyst. The definition of a catalyst is a substance that increases the rate of a chemical reaction, but the substance itself does not get consumed or used. After the reaction is over, the catalyst remains unchanged. The best example of this that the book talks about is the enzymes in your mouth. When your mouth produces saliva when you're eating, like nachos that are spicy and cheesy and gooey and hot. Right now all your mouths are watering. But that saliva is getting ready to aid in digestion. And so as you chew the food and you break it down and increase the surface area, the enzymes in the saliva are going to mix with the food and it's going to help digest it faster. In fact, digestion happens even before it reaches your stomach. So a catalyst is going to help speed up or aid in that chemical reaction.
And on that note, we're going to go get some nachos.
That's right.
All right. See you later.
Bye.